All right, welcome back. So we're time to get started with our playgrounds, our fake playgrounds, and we're going to get started with variables. So the first thing you're going to want to do is you're going to want to open up the project. So in the zip that you downloaded, you can see that there were three. Right, we played with the Swift Playgrounds translated last time, and I mean, if you want to, you can go through all of those and you can look at the details. But I decided to pick only certain ones out for us to do together. So go ahead and open up this project. Once you get it open, you can start looking around. So you can open up some of these things over on the left. I think probably the place that makes the most sense to start is in the view controller file. You can see that there's going to be only 5 playgrounds, so I reduced the number of playgrounds that we're going to go through. One of them is variables, so we're going to start looking at variables. So if you go ahead and run this thing right now, you'll get some logs, not a lot of logs. Oops, it was already running in the old one, so I stopped that and started up again. When you run it, you'll get some logs, not a lot of logs. It says the word variables. And if you go look at the variables.m file, so you notice that there is a .h as well, which we'll look at later. The variables.m, that's where that log is coming from, right? So what we're going to do is we're just going to go through talking about variables. The first thing you need to know about variables in Objective-C is it uses this concept of some variables are primitives and then some variables are objects. If you're used to Java, you're very used to this concept. There's a lot of languages that do it. It's only the newer languages like Python or Swift that don't make this distinction. Most of the older languages do. So let's just make a couple of these things. So if we wanted to make a primitive int, we could do that. That's been the same as what C's done for a year. If we wanted to make a primitive double, we can do that as well. If you want to actually print this out and see something, you're going to have to make an ns log, oops, a capital L in the word log. And you can do things like, say, x is equal to %d, d is equal to %f. You could also print out fewer digits if you wanted. And you could print out X and D. And then once you actually get something that you want to see, unlike a playground where it just shows up, here you have to run it, right? So you can see that X is equal to 7, and then D is equal to 1.234. So those are primitives. You'll notice that there's no star symbol when it comes to primitives. So that should hopefully be pretty easy for you. Can't imagine it's not. And then there are objects. So objects use a star, right? So star is something that Java got rid of whenever it introduced its programming language, but C still has it, and Objective-C still has it. So anytime you have a star, it means that this is really a pointer to something, which is how objects work in any language. It's just a matter of whether you type the star or not. So if we wanted to make an object which was a string, there's a shorthand for strings. So you can just say at in front of the double quote, and that's actually one really easy way to make a string object. Most objects work a little bit different than that. So you say star, I'm going to go ahead and make 2 ns numbers. One I'm going to call verbose number. And the way that you typically create things in Objective-C is you say the class and you say alloc, and then that's going to allocate the memory space for it. And then you call some initializer. You'll notice that with ns_number, there's a lot of init functions. I'm going to use the one that says init with int. So there I would make an ns_number object based on, it's kind of a wrapper around the integer 7. You can also use shorthand on ns numbers. And you actually saw this in the last video, right? So you can just put an @ symbol in front of it. Oh, I meant to make that one 8 instead of 9. So here's a couple simple objects. And then if you wanted to print these out, you would still have to do an ns log. So I'll say, hey, my string is equal to %at. Whenever you want to print an object, you always say %at. Doesn't matter what type of object it is. And then my numbers are %at and %at. You notice that even though they're numbers, they're objects, right? And so you always print objects with % and then the at symbol. And then you just want to type these things in here so that they all get printed. And then just like before, if you want it to actually run, you'll have to hit Command R to run this thing. And then down at the bottom here, you can see it says, my string is hello world, numbers are 8 and 9, right? So we've got this concept that we always have to worry about whether something is a primitive or an object, and that's kind of the first thing that I wanted to say about Objective-C. Just to kind of be consistent with some things we did in Swift, we could also declare constants. There's a couple different ways we can make constants. I usually like to declare my constants like outside of anything, so I declare my constants up at the top here. So there's a couple different ways to make constants. One way is what we showed before. You could just add the keyword const into the variable declaration. But to be honest, what I do even more than that, it's kind of old school, is I use pound defines, which is a preprocessor macro that C introduced. And what it really does is just anywhere it sees these characters, for this pound define, it just replaces it with this. So it's actually a fine way to make most constants. There are slight differences in how it works. And you can do the same thing with objects, right? So if you wanted to make an object be a constant, you do put const in a weird spot. I guess you put it after where you say what type of variable it is. That was a little surprising to me, but I just looked that up, and that's how they did it. I had to look that up because what I do a lot more is I use the pound define, right? So whenever I type my constant, I can actually just get this pound define for @world, and that works just fine. And to be honest, it's the pound defines that I use most of the time. Down in our code, I do want to print these things out. No need to watch me type it here, so I'm just going to say the numbers are %d and %d. Notice that these are primitives, right? So these two are just really old school ints. And then my string are objects, and so I can just go ahead and run this. And after I fixed my typo up here where I left out the letter S, it ran just fine. And you can see that it prints out the numbers 7 and 8, and then the string is actually hello, and then the string world, right? So those are constants, and they're actually pretty easy to use. The last thing I wanted to warn you about are primitives that don't look like primitives. You're like, is that a primitive or is that an object? And I call them sneaky primitives. The first sneaky primitive is NSInteger. So you're like, oh, what is NSInteger? I'm not really sure what that is. But I mean, NSInteger, what it does is it's meant to be whatever size the system is. Like if it's a 32-bit system, it'll be 32 bits. So it's the most efficient for that system. It's a 64-bit system. It'll be a 64-bit int. But it is still a primitive, right? So you'll notice that there's no star. There's other primitives out there like bool, which is just for a Boolean value. And it's a primitive, so you don't actually need a star in it as well. Bools, we mentioned this previously in Objective-C, are either yes or they're no, right? Which I think is really awesome. I love that feature. There are other sneaky primitives as well. So one of them is that you'll just kind of interact with some CG float. So CG float is a primitive. So here we'll say CG float is 234. You notice it says I don't know what this CG float is. That's actually because we imported Foundation instead of UIKit. So you actually have two options on imports. One thing you can import is UIKit, or you can import Foundation. It actually turns out that if you import UIKit, you get Foundation for free. So what I did here, I forgot how sneaky I did that. I went into the header file and changed that via Command Control Up. You could also just go to the header file in some other way if you wanted. But if I import UIKit instead of Foundation, you can see it knows what CG float is. There's actually a bunch of CG things that you'll run into over the course of Objective-C programming. One of them is CG rect. And these get confusing because there's all kinds of like helper functions for them. So if you wanted to make a CG rect with a 0, origin, width and height of 100, 100, there's a helper. I think it's probably a macro to help you make it. But don't be confused. It's not an object. This one is actually a structure, right? And then if you wanted to print these things out, you could. I won't make you watch me type that, but here as I'm printing that out, you'll notice that on Y, the NSInteger, it didn't really like me printing it as just an NSInteger, so I chose to typecast it as a long. You print out longs by saying LD. That cast is actually optional. It's just to get rid of warnings. I hate looking at warnings. And you can see that this thing worked great, right? So the bool is really just saved as a 0 or a 1. The NS integer printed fine, the float pointed fine, and then as far as the struct for the rect, I chose to print out only the width. I could have printed out the origin x, the origin y, the size.width, or the size.height. I chose to print out just size.width. So that one is a structure, so it's another sneaky primitive. All right, so that's kind of all we've got for the basics of variables. We'll come back next time and we'll talk some about properties. All right, see you next time. Bye.